Frank Dworak is back with a new JavaScript game tutorial featuring interesting physics and AI mechanics. He's included custom-made royalty-free assets for you to use, and he'll guide you step by step to create a polished and responsive browser-based game.
What makes a perfect game? Detailed handcrafted visuals, fantasy environments, and a wide variety of animated characters? Or is it more about the game mechanics, physics for interactions, and AI to make the creatures feel alive? What is the special ingredient in game development recipe? In this class, we will dive deep into the secrets of JavaScript, web animation, and front-end web development. Let's try to discover what makes a great game and how we can build it from start to finish using just our own JavaScript code with no frameworks and no libraries. This class is for beginners, but some basic knowledge of front-end web development is required to get the maximum value. Let's go! I'm giving away a ton of free game art with this class. I hope you like it. We will control the blue bull. Its job is to protect Hatchin X from waves of hungry enemies. Player can position all the game objects by pushing them around. We can push the X and hatchlings to safety, or we can push the enemies out of the way. While building this project, I will show you how to use HTML, CSS, and plain vanilla JavaScript to implement many important web animation and game development techniques. We will apply physics to make important web animation and game development techniques. We will apply physics to make game objects interact with each other. We will learn how to restart our game by pressing a button, how to control FPS of the whole game, how to trigger periodic events. We will apply mouse controls, learn how to manage and animate 8 directional sprite sheets. We will trigger and animate particles when a certain event happens, and much more. Let's take it step by step to make sure we really understand the code, and by the end of this class you will have all the skills you need to build your own games and animation projects. I create an IMG element with an ID of overlay. The source will be overlay.png. You can download all project art assets in the resources section below. There are individual images and sprites as I'm using them in this class, as well as a bonus folder with source files where each game object comes split into high-resolution pieces you can edit and animate. So if you want, you can mix and match, combine them with art I gave you for other classes where we are using this mushroom forest theme, and you can create your own unique game environments. All the art in this class is copyright free. Feel free to download them, modify them, and reuse them in your own projects in any way you want. I'm already giving you all art you will need to follow this course, but for those of you who want to take it further, if you have a graphics editor like Photoshop, you can, for example, color shift the images to create even more visual variety. Character source files can also be rigged and animated in 2D sprite tools like Dragon Bones or Spine. Check out the source files and use them however you want. It's my gift to you as a thank you for spending your time with me. So we have a basic setup in index.html and style CSS. Canvas defaults to this small size of 300 times 150 pixels. If I set its size with CSS, I would be setting only its element size, and that would stretch my drawing. settings. HTML canvas has actually two sizes, element size and the drawing surface size that can be set independently. I want both sizes to be the same to prevent any distortions, so I will size my canvas with the JavaScript here. I wrap everything inside load event listener because we will use a lot of art assets and I want to make sure all my images are fully loaded and available before any JavaScript code runs. First, we need to point JavaScript towards our canvas element using getElement by ID. We save that reference in this custom variable I call, for example, canvas. Then I take that variable and from it I call built-in getContext method, passing it 2D as context type argument. This context. First, we need to point JavaScript towards our canvas element using getElementById. We save that reference in this custom variable I call, for example, canvas. Then I take that variable and from it I call built-in getContext method, passing it 2D as context type argument. This will initialize a built-in object that holds all canvas properties and drawing methods. We can now call them from this ctx variable. So as I said before, I want to set canvas size, both element size and we can now call them from this ctx variable. So as I said before, I want to set canvas size, both element size and drawing surface size to the same value. We can do it like this. Canvas.width is 1280 pixels and canvas height is 720 pixels. Now the full background artwork I prepared for you is revealed. Perfect. I want to write this game as object-oriented codebase to make it more modular. We will have a class for player and another class for game to manage all the game logic, the main brain of this codebase. We will also need animation loop to draw and update our game over and over to create an illusion of movement. Game class constructor will expect a reference to canvas element as an argument like this. Inside, we convert it into a class property and update our game over and over to create an illusion of movement. Game class constructor will expect a reference to make it more modular. We will have a class for player and another class for game to manage all the game logic, the main brain of this code base. We will also need animation loop to draw and update our game over and over to create an illusion of movement. Game class constructor will expect a reference to canvas element as an argument like this. Inside, we convert it into a class property, and we will need width property, and the value will be this.canvas from line 15 dot width like this. This will give us 1000 280 pixels as we set it up on line 4. We do the same thing for this.height. We are taking a reference to canvas element and we are setting the width and height of our game to be the same as the width and height of canvas. We will finish this setup by connecting this canvas argument to this canvas variable a little bit later when we create an instance of our game class using the new keyword. We will get there soon, I'll show you. Before we do that, I also need the player to have access to width and height properties of our game, because the player needs to know, for example, when it moves outside the game area and so on. I will give it access to the entire game class and all its properties and methods by passing it a reference to this game class as an argument, like this. Inside, we convert it to a class property. Keep in mind that I'm not creating a copy of game object when I create player. Objects in JavaScript are so-called reference data types, so this.game here on line 9 doesn't create a copy. It just points to a space in the memory where our main game object is stored. All the code points in the path will give it access to the entire game class and all its properties and methods by passing it a reference to this game class as an argument, like this. Inside, we convert it to a class property. Keep in mind that I'm not creating a copy of game object when I create player. Objects in JavaScript are so-called reference I will give it access to the entire game class and all its properties and methods by passing it a reference to this game class as an argument, like this. Inside, we convert it to a class property. Keep in mind that I'm not creating a copy of game object when I create player. Objects in JavaScript are so-called reference data types, so this .game here on line 9 doesn't create a copy. It just points to a space in the memory where our main game object is stored. All the code inside a class constructor gets triggered when we create an instance of a class using the new keyword. We will do that in a minute. I want our codebase to automatically create player when we create an instance of our main game object, so I can do this. Inside the class constructor, I create a property called this.player. And I set it to new player like this. I can see that player class constructor on line 8 expects game as an argument, so I pass it this keyword, since here we are inside that game class. This keyword here refers to the entire game object. Here on line 18, we are creating an instance of player class and we are saving it as a this.player property on the game class. Structuring our code like this will automatically create player when we create game. We create an instance of game object like this. Custom variable I call, for example, game, and I set it equal to new game. On line 14, I can see that the game class constructor expects canvas as an argument, so I pass it canvas variable from line 2. This This variable will get converted to a class property, and the width and height of the game area will be extracted from it as we planned. Let's check if everything worked by console logging this. Game variable. Nice, I can see the correct width and height properties, and we have an instance of player class in there as well. This is one of the ways how you can organize and connect your objects in an object-oriented JavaScript codebase. Keep in mind that the order in which we define the classes matters. JavaScript file is read line by line from top to bottom. JavaScript classes are hoisted, but they are not initialized until that particular line is read. So player class needs to be defined before it's used. A very good idea would be to split our JavaScript into individual modules and import and export our classes between files as needed. For this project, I will write all the code in a single JavaScript file to keep it as beginner-friendly as possible. Using JavaScript modules would require us to run this code through a local server. It wouldn't run the code by simply opening index.html file in a web browser anymore. If you are more experienced, it will be very easy for you to finish the project with me, and then if you want, you can split individual classes into separate modules yourself. This class is for beginners, so let's focus on object-oriented principles and animation techniques. A function that sits on an object is called a method. Player will need a draw method to draw and animate it. It will expect context as an argument. To specify which canvas we want to draw on. We will connect this context argument to our ctx variable from line 3 when we call this draw method a little bit later. I will show you. I want to draw a simple circle at first, representing our player. To draw a circle on canvas, we take context and we call begin path to tell JavaScript we want to start drawing a new shape. And we want to close previous shape if there are any. Then we call call built-in arc method, which expects at least 5 arguments. It expects x and y coordinates of the center point of the circle. It radius, start angle in radians, measured from the positive x-axis, and end angle, where the arc ends, again in radians, measured from the positive x-axis. angle, we call built-in arc method, which expects at least 5 arguments. It expects x and y coordinates of the center point of the circle, its radius, start angle in radians measured from the positive x-axis, and end angle, where the arc ends, again in radians measured from the positive x-axis. There is an optional 6th argument for counterclockwise. If we don't define it, it will default to false, which means that the arc will be drawn clockwise. So start angle is 0 radians, and end angle is math.pi times 2, it's a full circle. Now we can choose to call fill, to fill the shape with color, or stroke. Just to outline the shape, or we could use both. We will do that soon. How do we actually draw the player on canvas now? On the game class, I create a method I call, for example, render. This method will draw and update all objects in our game. It expects context as an argument. Inside, I take this.player from line 23, and through this reference we access the draw method on player class we just defined from line 11. This method contains the code to draw a circle representing the player. I can see it expects context as an argument, so I pass it along. This context we passed to the render method. Now I can take this game variable that holds an instance of the entire game class and from there I call render. And I pass it ctx. From line that CTX will be assigned a variable name context here, and it will be passed along to draw method on player class. Nice. We are drawing a black circle representing the player. It's here. Maybe you can't see it, so let's give it different x and y coordinates to move it. Instead of hard-coding all these values, I want to create properties on the player class and then use those here. We will need x and y coordinates. For player position, but because in this class we are learning about position in hitbox, boxes and character images that can have very different shapes and sizes, I will have to create property for x and y position of player hitbox, and I will need to have a different x and y property for player sprite sheet image. It will make more sense as we build it. I want to be very explicit with my variable names to make it absolutely clear which value is the position of the collision box and which value is the position of a sprite sheet. So instead naming these properties just x and y, I will name them collision x and collision y, x and y position of the collision hitbox, of the center point of the collision circle. All objects in our game today will have circular hitboxes because I want to show you how to make them push and slide along each other. I want the starting position of the player to be exactly in the middle of the game area, so collision x will be this.game from line 9, and from that property I will extract width from line 23. And in the middle, so times 0.5. Collision y will be the same, this.game.height times 0.5. Now I can use these values as x X and Y arguments pass to canvas arc method, like this. Now we can move the player around by changing values of collision X and collision Y properties. We will also need a property called collision radius, which will define the size. Of this circular player hitbox. I use it here inside the arc method as well. Default fill color is always black. I can override it here by setting canvas fill. Fill style property to white, like this. Instead of filling the shape with color, we could also just stroke it. Again, by default, line width of stroke is 1 pixel and the color is black. I set line width to 3 pixels and I set stroke style to white. Notice I'm defining these canvas properties outside of any class or method. I do that on purpose because this code will only run once on the initial page load. You can't always do that if you have multiple objects with different fill styles and stroke colors. In that case, you would have to define these properties inside the draw method and switch between them over and over. The problem with that is that the draw method will be called 60 times per second, and changing canvas state like this could get performance expensive. It's a good idea to structure your code in a way where you change canvas state as little as possible. And when I say canvas state, I mean anything from transforms to changing colors of fill style and stroke style. That's why I put this code here instead of placing it directly inside the draw method, to make it run as little as possible while still applying the colors and settings as I need them. I can also call fill here. So now we are filling and stroking the same path defined by arc method. I want the fill to be white, but I want it to be slightly transparent. Canvas has a global alpha property to set opacity of the shapes we are drawing. The problem is that when I set global alpha to a different value, everything drawn after that will be semi-transparent. I want the transparency to only apply to the fill color of player collision circle. To limit certain canvas settings only to specific draw calls, we can wrap that drawing code between save and restore built-in canvas methods. Then, if I set global alpha to 0.5, it will affect only that specific drawing action. In our case, it will only affect the fill of this circle. So, save method creates a snapshot of the current canvas state, including its fill style, line width, opacity, as well as transformations and scaling. If we are doing that, then I can do any changes to that canvas state I want. In this case, I just set opacity to 0.5. This fill call will be affected by that changed opacity, and then we call restore, restoring all canvas settings to what they were when we first called its associated save method. For that reason, this stroke will not be affected by reduced opacity. Save and restore methods allow us to apply specific drawing settings only to selected shapes without affecting the rest of our canvas drawings. Shapes without affecting the rest of our canvas drawings. I want to move the player around using mouse. We already know that the code inside the game class constructor will be executed at the point where we create an instance of this class using the new keyword. We are taking advantage of that by automatically creating an instance of player class here. We can actually run any JavaScript code in here. I can even put event listeners here to make sure they are automatically applied when I create an instance. I want to move the player around using mouse. We already know that the code inside the game class constructor will be executed at the point where we create an instance of this class using the new keyword. We are taking advantage of that by automatically creating an instance of player class here. We can actually run any JavaScript code in here. I can even put event listeners here to make sure they are automatically applied when I create an instance of game class. I create an event listener for mouse down event. When mouse button is clicked, the code inside this callback function will run. I test it by just console logging the word keyboard, mouse down. down. If I save changes, because I'm already instantiating this class on line 46, this event listener is automatically applied. Now when I click on canvas, console log is triggering. Nice. Callback function on event listener auto-generates an event object that contains all kind of information about the event that just happened. To get access to that object, we just need to give it a variable name. You can name it whatever you want, but the convention is usually event or E. Let's console log this event. I click on canvas and I see it here. I inspect it. You can see it contains a lot of information about that mouse click. For example, we see X and Y coordinates of that click here. There are many other properties that tell us which mouse button was pressed and many other things. I want to take the coordinates of the click and save them as properties on the main game object, and from there we will be able to access them from our player object as well. I create a new property on game class called this.mark properties on the main game object, and from there we will be able to access them from our player object as well. I create a new property on game class. We see X and Y coordinates of that click here. There are many other properties that tell us which mouse button was pressed and many other things. I want to take the coordinates of the click and save them as properties on the main game object, and from there we will be able to access them from our player object as well. I create a new property on game class called this.mouse. It will be an object with X property with default value of this.width times 0.5, and Y will be this.height times 0.5, so the middle of canvas, horizontally and vertically. We will also want to monitor when the mouse button is pressed down. Initially, it will be set to false. If I console log e.x and e.y, you can see we are getting X and Y coordinates as we click around canvas. The problem is that the coordinates are from the top left edges of the browser window. I would like to measure the click coordinates from the top left corner of canvas instead. So when we click here, in the top left corner of canvas, we get X and Y 0, 0. For that, we can use a different property on this auto-generated event object called offsetX. X, which will give us horizontal coordinate of the click on the target node. In our case, the target node, the target of the click, is canvas element. Now you can see the values get very close to 0 as I click close to the edge of canvas. I could also add the event listener just to the canvas element itself rather than the entire browser window object. If I click closer to the top left corner, we are getting values close to 0, 0. Perfect. Probably it would make sense if I use this.canvas property here from line 31 instead, since we are inside a class and we have the reference to canvas available here. So now we are getting coordinates of the click measured in pixel distance from the top left corner of canvas. Even when we resize the browser window, this is working well. I want to save these click coordinates inside our custom mouse property so that they are available to other objects in our codebase, such as the player. Inside the mouse down event listener, I take that this.mouse.x property from line 36 and I set it equal to e.offsetx. This.mouse.y will be e.offsetY. I create another console log and I will log these newly updated mouse properties. When I click on canvas, we get an error that says cannot set properties on undefined, set in X on line 43. It's telling me that I can't set X property on something that is undefined. For some reason, this.mouse is undefined when accessed from inside event listener. It is because when this callback function on event listener runs, it forgot it was originally defined inside this game class constructor. It forgets what this keyword stands for. This is expected. To make the event listener remember where it was first defined, where it sits in the lexical scope of our codebase, we can simply use es6 arrow function. here instead. One of the special features of ES6 arrow functions is that they automatically inherit the reference to this keyword from the parent scope. Arrow functions, remember, where in the codebase they were originally declared lexically, and they adjust their this keyword to point to the correct object, to the parent object. Now, this.mouse.x and this.mouse.y are correctly updating to the new values, making the current mouse coordinates available all over our code base whenever they might be needed later. I delete the console logs. When mouse down event happens, I set press from line 38 to true. I copy this event listener. This one will be for mouse up event. When the mouse button is released, everything here will stay the same, and we set pressed to false. I also create an event listener for mouse move event. Let's console log it to check. Yeah, that's working. Let's make the player move. I create a custom method I call